Hey guys, the objective of this video is to find the pure bending case. It's an iterative process, so this section might span a couple videos, so just stay patient, guys. Now, to do the pure bending case, there's no axial load applied to this. So what we're going to be doing is we're going to be assuming that at the start, all the steel is elastic, so it hasn't yielded yet, so all the steel is elastic. And we're also going to assume that the strain in E1 and E2, so this layer here and this layer here, are compressive. Okay, so we're just going to assume that to start. As we go through the process, some of our assumptions might be incorrect, and then we have to adjust our process. So we're assuming that they're in compression, E1 and E2, so the steel in layer 1 and the steel in layer 2, and we're going to call this E3, and we're assuming that they're all elastic. Okay, so it's just a good place to start like that. So what we're going to do is we're going to come up with an equation for dn for all of our strains. So unlike all the previous videos where you could easily find dn, for this case you can't easily find dn. We're going to see now you're going to be solving a quadratic to find it. So it's not so simple to do, and you also need to take several assumptions in order to solve for it. And as I say, you'll find that some of those assumptions are incorrect or correct, and that's why it's an iterative process. So let's find the strain in layer 1. So similar triangles for this triangle here and the bigger triangle there. So E1 on point 003 equals. So we're going to be doing that length on that length to that length, which is dn minus 15. 15 is the length from there to there. That's dn, so that length would be dn minus 15. Divided by the corresponding length to point 003. So that would be from there to there, which is dn. Solving for this, we would find that the strain in layer 1 is 0.003 outside of dn minus 15